Hello and welcome, Woodrow Wilson friends, family, and students. This is Miss Fields here, and I'm joining you tonight for our 22nd episode of Math Toolbox. Tonight we're going to be focusing on a skill that kind of culminates all of the other skills into one. So instead of just translating data into ordered pairs and then plotting them, we're actually going to start from an unlabeled plotted point, turning it into an ordered pair or labeling it, and then creating that into a data table. So this is kind of all of the skills that we've learned in one. Now, in looking at this, the first quadrant of this coordinate plane, this is something that our fifth graders would encounter in kind of having to reverse engineer everything that we've learned previously. So on our x-axis, which goes from left to right, and our y-axis, which goes from top to bottom, we've only got positive numbers. So whenever we're trying to figure out what a plotted points ordered pair is, we always start at the origin. So in preparation for putting these ordered pairs into a data table, we are going to create a vertical data table in which the x and the y are side by side, left to right. And then we're also going to create a little column here for labeling the actual fruit or vegetable that we are going to identify with an ordered pair. Now previously we learned that in our vertical data tables, the x is always on the left and the y is always on the right. Now if we were to create this into a horizontal data table, the x would be on the top and the y would be on the bottom. So in starting with our first vegetable, we're going to look at an eggplant. Now, in order to identify the ordered pair of the eggplant, we need to start first with our x-coordinate. And we know that our x-coordinate always slides. She's the lady in the ordered pair relationship. She slides. And so we're going to start there. We know that that's the first part of our ordered pair. And now we need to drive all the way up until we finally meet our eggplant, which is 10 units up the y-axis. Our ordered pair is 110. And you just put those two numbers in your data table, no parentheses, no comma to separate them, and that's what it looks like in a data table. Moving on to the next item, we've got an apple. So we're going to start at the origin, and then we are going to slide 4 units to the right until we see that the apple is directly above us. And then we are going to drive until we collide with that apple, which is 9 units up the y-axis. Our ordered pair is 4, 9, and that translates into 4 and 9 in our data table. Moving on to the watermelon, same exact process. You're going to start at the origin, and you are going to move 2 units right on the x-axis until you see that the watermelon is directly above you. From there, you're going to move as many units up the y-axis as necessary until you collide with that watermelon, which happens to be 7 units. So our ordered pair will be 2, 7. Same exact thing, take away the parentheses, take away the comma, and put that 2 and 7 into your data table. Moving on to the radish, same exact process, slide 3 units to the right on the x-axis, drive 4 units up the y-axis until you collide with that radish. Our ordered pair is 3, 4. Take away the parentheses, take away the comma, and you've got your data units in your data table. Now, if we were to do this in reverse, we know that in our vertical data table that the units on the left are our x-coordinates, the units on the y are on the right, are our y-coordinates, and we know that we group them together. So we know that this would be one ordered pair 110, this would be one ordered pair 4, 9, this would be one ordered pair 2, 8, and this would also be one ordered pair 3, 4. Moving on to our next vegetable and fruit, we've got a tomato. In order to get to our tomato, notice I didn't put our lines here, so we're going to have to do this off of memory. You can trace your finger on the x-axis. Previously in our class, we actually used our bodies and our class size graph to slide and drive. I'm going to use my cursor. Starting at the origin, we're going to move as many units on the x-axis as necessary. It looks like that's 7 units on the x-axis. And then we're going to drive as many units as necessary, which looks like 3. Our ordered pair is 7, 3. Translate that into our data table. Next up, we've got our pineapple. Slide 5 units on the x-axis, drive 2 units up the y-axis, and we get 5, 2 as our ordered pair. Next up, we've got our strawberry, which is over here. So we're going to slide, starting at the origin. We're going to slide 6 units on the x-axis, and we're going to drive 8 units up the y-axis. Our ordered pair is 6, 8. Again, I want to note, make sure that you put your parentheses around your numbers and your comma in between. If you were just to put 6, 8, somebody looking at your points might think that you're putting 68 as the labeled point on your data table or on your graph, and that wouldn't make sense to them. If you don't have your parentheses as well, we wouldn't know that those numbers are grouped together. So it's really important that you incorporate all of these elements in order to effectively label your points on a coordinate plane. And then also know that whenever you translate that into a data table, you take those away. Moving on to our onion, we're going to slide 8 units on the x-axis, and we're going to drive 1 unit up the y-axis to get 8, 1. For broccoli is all the way over here, starting on the origin. We're going to slide 9 units on our x-axis, and then we're going to drive 5 units up our y-axis. Our ordered pair is 9, 5. Same exact process for our pair. Starting at the origin, which is 0, 0, we're going to slide 9 units on the x-axis, and then we're going to drive 7 units up the y-axis, and our ordered pair is 9, 7. Our pepper, starting at the origin, we are going to slide 8 units on the x-axis, and we're going to drive 9 units up the y-axis, and our ordered pair is 8, 9. Let's see if you can do this last one on your own. We've got our nice little pumpkin, and we've also got this mystery vegetable or fruit. I'm not exactly sure what it is, so I didn't even include it in our data table. If you'd like, I'd love for you to figure out whatever it is for me and also identify where it is located on our coordinate plane. So try and figure that out on your own. If you can't, make sure you just continue on in the video and I will explain how to do it. With our pumpkin starting at the origin, we're going to slide 5 units on the x-axis, and we're going to drive 6 units on the y-axis. How did you do? Did you do it accurately? If you're still struggling with this skill, no worries. Contact me, rewatch the instructional video, rewatch the other instructional videos which explain how to translate these data points into ordered pairs, and continue practicing this skill on your own. There's lots of fun different games that you can do and challenge yourself in just plotting random points onto a coordinate plane and doing your best to identify them. Of course, it gets a little bit more complicated whenever our x-axis or our y-axis has fractions. However, just for this point, this stage in our learning on coordinate planes and plotting points, we're just going to focus on whole numbers. However, in the next upcoming weeks, we will be focusing on fractional lengths on our x and our y axes. And if that gives you any trouble, be sure to contact me and I will help you out. Have a wonderful night. Can't wait to see you guys in the morning.